Greetings all LinkedIn professional. It's been a while since my last tech video posting. Started exploring more on the Linux operating system. When you really want to build the industry standards enterprise applications, I realized there is a need to switch over to the Linux from Mac. Okay, so because open source operating system has more luxury and comfort to do the things which you wanted, replicating the actual real world enterprise applications. Gone are the days where learning Kubernetes was as simple as installing Minikube locally in your machine and creating a basic container with start.springer.io, spin up. These are all good for the basic understanding, for the very basic understanding. But when you come to the real world applications, it's totally different. Without having solid hands-on experience with the multi-node Kubernetes in the cluster, so and the real world production settings, you won't be able to provide any promising solution that meets the performance, scalability, and reliability. So keeping all these things into consideration, I have migrated to Linux, purchased a Windows laptop, completely erased the Windows and installed the Ubuntu open source software here. Okay, so I used multipass for this one, which is a VM open source VM manager from Ubuntu again. So I installed 4 VMs here. Clear multipass list. If you see here on all these 4 VMs, one VM I created for the applications, both for Java microservices and another one for the Angular micro frontends applications. Data 1 and data 2 VMs, I want to use it for Kafka and database setup. And K8's master is for the master node Kubernetes, which is a control plane. Okay, so I have the Kubernetes installed on all these machines. 1, 2, 3. These 3 are worker nodes, and this one is a master node. Okay, let's get into the master node Kubernetes through multipass shell commands. K8 dash master. You are into the master node, and if you give here kubectl get pods, there is only one sample application which I deployed that's running, but there's even more you need to explore. If you go here kubectl get pods -a, this is where you need to explore a lot. See the Calico node, is the application image, Calico node, core DNS, Kube API server, Kube controller manager, so all the Kube scheduler. So these are all the internal pods of the core master plane Kubernetes. Let me give you some important details about the critical nodes of the internal master node. One is the Calico node here, which you are seeing, handles Kubernetes networking and policy enforcements. Basically, it is one that connects to the pod IP directly, pod to pod service, external network routing. And when you go level up, that is a kube proxy. Kube proxy is the one that manages the network rules at the node level that comes from the external outside of the VM. Okay, the another critical node is a kube scheduler, assigns newly created pods to the most suitable node based on the resource availability and scheduling policies. So these are all some of the critical nodes. Let me show you one more hierarchy. If you observe here, there are 3 IP addresses for each of these nodes. One, that is the IP address of the VM. Second one is the IP address of the Kubernetes cluster, which is not accessible for the outside world. This is called as a cluster IP, and this is typically what we call as a node port IP. And the last one is the pod IP. Uh, any services running on the pod are communicated from the cluster IP to this IP via this IP address. So I still need to explore in detail on what these IP addresses and how those are how those can be translated to the DNS. Want to create an internal DNS service where the IP addresses you can transform it into the actual website address, the IP address lookup, etc. The DNS I want to do that. So how the communication will happen is from the VM. If you see this is a VM, from the VM first, if you develop any application and deploy it as node port, that means that particular application is accessible from the outside world. Say for instance here from the host machine, that application can be accessed through that IP address, which is the VM IP addresses, and the second one is the cluster IP. The cluster IP is the IP address at the Kubernetes service level, as I said, and the third one is the IP address at the pod level, which is where the actual application is running. Now, coming to the memory management to avoid pods crashing or node crash or VM crash, let me give you some important information about the memory management. Go here, free minus h. This will show you the total available memory on my host machine, which is 18 gigabytes is available. My machine, which I built it is 30 gig. Which I purchased is 30 gig RAM, and I kept 8 gig RAM for the swap memory in case if this 30 gig reaches its peak, the extra memory will be swapped from this swap memory. Okay, and I cannot go beyond 30 gig memory because the RAM here it's a different type of RAM. It is soldered, not the DDR regular RAM. What is the advantage of that one is you cannot expand the memory like free slots on DDR RAMs. It's a fixed memory, and the max memory which I already decided before purchasing the laptop itself, the memory is soldered to the motherboard of the computer. Okay, so let's go inside to know the or else within outside itself either you can know about the VM, how much memory you allocated for each VM. I allocated more memory for apps because this is where the Java and Angular applications will run, and data 1 and data 2 also I gave enough memory allocation as the database and Kafka are going to run, and K8's master also gave enough memory. So coming to the Kafka here, I installed Kafka in the Kraft mode. Okay, so in the Kraft mode, the Kraft which replaced the Zookeeper is running on this K8's master control plane, and broker 1 and broker 2 are running on data 1 and data 2 different nodes. So this is the ideal way which I selected. I can go for one more node, but I really don't want to push too much because it's everything is running locally in one machine right here. One of the reason, as I said, I don't want to go for any external cloud providers because once you launch there by mistake, if you forget, you have to pay for the hourly fee and all. But why? And everything you can have it in your control, and you can relate or build any applications uh, more like a real world applications, and you can set your own firewall rules, etc. Security is still one area which I need to explore and start installing for the connectivity. Yes, so that's down the line. I have to start looking in it. First goal is this multi-node Kubernetes setup.